Hi, I'm Gavin Newlands, and I'm going to run through a new functionality we've added to Oasys 18, running LS-DYNA directly from Primer. A common procedure for running large models in LS-DYNA is thus. Your model is written from Primer and then potentially transferred to a disk local to your HPC or cloud provider. Results and data are then transferred back to Inform, which will likely lead to model fixes, design changes, and iterations. Sometimes this process is time-consuming for the particular task you have. It's often useful to use the power of LS-DYNA to carry out smaller tasks, such as initializing and checking your model, or checking the output LS-DYNA produces is what you are expecting. Being able to run LS-DYNA quickly, directly from Primer, would help to streamline these types of processes. And we have been introducing functionality to aid leveraging the power of LS-DYNA for a few releases now. One of the main examples here is the LS-DYNA output checking tool in Oasys PRIMER. With this tool, you can read the standard output files produced upon initialization, and Primer will allow you to interactively visualize and investigate that data. The first part of this tool relates to errors and warnings in your model. The errors and warnings produced by LS-DYNA are captured and presented in an interactive tree. You can easily visualize and fix the entities referenced in those messages. Next, you can view information on how LS-DYNA is separating its calculations across multiple CPUs. Which contacts are the most expensive, and what changes can you make to improve the efficiency and load balance of your model? You can also investigate and visualize how your model is decomposed, which usually can be particularly difficult to determine when setting up your P-file information for decomposition. So these are all examples of where you can use LS-DYNA and Primer combined to investigate your models. To aid these processes and to carry them out in the fastest, most efficient way, we've introduced a tool to allow direct submission to LS-DYNA from Primer. This uses the power of the Oasys shell, Oasys's dedicated LS-DYNA submission tool. With this incorporated into Primer's functionality, initializing and checking your models becomes a quick and painless process. So this tool allows you to easily submit a model into LS-DYNA directly from Primer. The model can be submitted locally or onto a remote machine or cluster. As well as speeding up the submission process, the functionality allows easy initialization and model checking with a few clicks. To aid the above, this functionality has been integrated with Primer's LS-DYNA output checking tool to speed up the process of initialization when checking models and visualizing decomposition and load profiles. So here we have a model read into Primer. This is a simple model with a crush rail impacting a flat plate. We would like to run this in LS-DYNA. We can now do that very easily using Primer's submission tool. Simply go to Model, Submit. The submission panel contains various options for how you want to submit the analysis. For this example, I want to submit locally. There are also options for submitting remotely on an HPC as well. So here I've already set up a bookmark that specifies my setup. Note I can choose to rewrite the model or run the model as already written. With just a couple of clicks, my analysis is now running. And you can see here we now have a job monitoring panel as well within Primer. My analysis is now running and being monitored. You have various options on this panel to kill the analysis or view the text output files. So as you can see, my analysis is now running and the job status will be updated periodically. So it's now 7% completed. So after a few minutes, the analysis has finished. Note you can continue using Primer while the analysis is running in the background. You can now look at the results. The quickest way to do that is to open the Oasys Postprocessing applications directly from within Primer. Click on the Post button at the top to open D3 Plot in just a couple of clicks. D3 plot will automatically read in the output results that have been generated. So here we have D3 plot opening with the linked results. And in D3 plot, you can now look at the results. So animate the results, do some contour plots, and so on. So now we have the ability to run models directly in LS-DYNA from Primer. We can add value to Primer's current functionality. One thing we have done is link this functionality to the checking tool. So now we've included the ability to initialize your model in LS-DYNA to make it easier and quicker to check your model. So here we have our example model again. I want to do a quick initialization to look for errors and warnings. So first you go to the Check LS-DYNA panel, and we have a new option here to initialize the model in LS-DYNA. When we select that option, we have access to the submission panel again. Note here though, Primer is automatically specifying the required options and settings for initialization. We don't want to run the full analysis. So once complete, here you can see it's completed quite quickly, we can interactively investigate any errors and warnings that have been identified by LS-DYNA during initialization. So here, for example, we can look at some contacts that exist in the model where we are seeing some warnings and we might want to investigate them further. So if we have a local installation of MPP LS-DYNA, we can use that in the checking tool. This is beneficial for checking load balancing and decomposition. So here we have our example model again. Let's initialize, but this time turn on the options for decomposition. We set numproc value to however many CPUs we want to test. You may run on an HPC with 16 CPUs as standard, but want to check how this model will be decomposed locally first. So we're not actually running on 16 CPUs, but setting numproc equals 16 tells LS-DYNA to carry out the decomposition over 16 CPUs so you can visualize the results. The submission process is similar to SMP, but for MPP, you do need an MPI installation. So after a minute, the initialization is complete. So once complete, we can now access the output file reader panel again. And this time, as well as the errors and warnings, we have access to the load profile information. And finally, with the last tab, we can visualize how the model is being decomposed. There we go. This is now how LS-DYNA automatically splits up this model into 16 separate chunks. The benefits of working this way are you can quickly check changes in your model. So here we're specifying p-file information to change from the default LS-DYNA decomposition. It's often difficult to easily visualize exactly how your model will be decomposed when defining the p-file information. But with this tool, we can make changes to the p-file and see the results of the initialization in a couple of clicks. So again, we are submitting into the submission tool for initialization. So after a minute, that model has been initialized, and we can once again look at the output file reader, and we can visualize how this model has been decomposed. So in this case, the P file has been used, and it's been decomposed into slices in the Y direction. So really quick and easy for you to check how your model will be decomposed in MPP LS-DYNA. So please do give this new feature a try and check out the other presentations available for the Oasys 18 new features.